So how is going from this going to give you the results like this? It's about getting to the root problem. Hey everyone, it's Dr. Heather, your virtual sports chiropractor, and today we're going to really dive into nutrition, especially nutrition when it comes to endurance athletes. And when I say endurance, I mean our long distance types of runners, the half marathon, the ultra runners. That's what we're looking at talking about today, because we see this all over social media. What should I be eating in order to really have a good run to complete without noticing any cramping, noticing any fatigue, and then the next day having a really good recovery period without feeling like you can't go to the bathroom and you can't climb those stairs? So that's what we're going to really dive into today. We're going to be talking about why you might want to eat more protein and fat in order to achieve the endurance event that you're looking at doing. So we're going to go into it today, and we are going to go through a lot. So be prepared, hang on, because there's a lot that we're going to discuss right here. Now, guys, I don't want you to feel overwhelmed when we talk about this, but I really want you to pay attention, because I'm going to give you some real strong key takeaways that are going to help you in feeling very successful in that event. And as you can see from my slide here, we're talking about pretty much fat and protein is going to equal endurance. And you might be saying, okay, well, how does this work? How is our body going to know to really utilize these two macronutrients to help us achieve that endurance event? Well, that's what I want to go through with you guys, because I think we all have seen this, and I love this meme. I love this meme so much because I think it's just classic. And I'm going to reshare it. I did it in a small little video when we talked about nutrition for injury prevention. And, here you have the kids, pretty much taking the pasta, pushing it right into his mouth, and, talking about carb loading essentially before a run event. Now, if you were a high school athlete, if you are a parent of a high school athlete, you may know about pasta dinners. That was something my generation did. Before the event, everybody'd gather together, big potluck, and we'd have a pasta dinner because we were under the assumption that carbs is going to help us achieve that event. That's true, but also not true. And that's where we're going to really start talking about things a little bit more. So if you're unfamiliar with science, if you're unfamiliar with physiology in terms of how our bodies take the food that we eat and what happens to it to produce energy, we're going to look at that a little bit further. And that's a cycle that's done on a very molecular level known as the Krebs cycle. It also has a few other names known as the citric acid cycles, and it's a series of enzymes that catalyze into a reaction occurring in the mitochondrial matrix, where acetylcholine is going to be oxidized to form carbon dioxide. Coenzymes are reduced, which generate ATP in the electron transport chain. Now, if you feel that's a mouthful, this is going to really start blowing your mind, because this is actually what happens on that cellular level. It's a very complex process that happens within our bodies to really allow us to produce energy. Now, you might be this individual right now going, what the heck did she just say? Because I am so confused. I have no idea what she just talked about. All I want to know is really how eating protein and fat is going to equal more energy for me. Okay, well, if you are like this individual on this slide right now who's going, okay, you really lost me, we're going to simplify things, okay? So we're going to break it down into a few steps, and I've got 5 basic steps for you guys, which I really want you to pay attention to. Okay, so we eat our food, okay? We're out at dinner the night before the event. The food then enters our digestive system. It's broken down into our small intestine, into carbs, fat, and protein, so our muscles can access this for energy. So the carbs and fat then enter our system on a cellular level known as glycolysis. This is where glucose will be broken down further, and we're going to talk about that a little bit more. And then next, the carbs, fat, and protein enter that Krebs cycle, which I just mentioned to you, which then are broken down into energy. And then from there, the energy is released into our muscles. So it actually is a very simple process, although some of the stuff I showed you on the previous slide may have seemed a little bit more mind-blowing than we really want to have. So let's take this now into a little bit kind of greater depth. So we all are familiar with the term macronutrients. And like I said, macronutrients, that's our fat, our carbs, our protein. And this is what I want you guys to really take away here. Proteins are broken down into amino acids and polysaccharides into sugars and fat into fatty acids and glycerol through the action of specific enzymes. Following this process, the smaller subunit molecules then have to enter the cells of our body. They firstly enter the cystole, the aqueous part of the cytoplasm of a cell, where the cellular respiration process begins. So what I want you to take away from this is understanding when we actually go out at dinner, and again, using that first example that I have of that really nice Mexican meal where we've got the right amount of carb coming from rice, we've got our protein coming from chicken, maybe some steak, and then maybe we're using some guacamole, which is going to be our fats, where we're getting some good fatty acids. Our body initially takes that down and starts breaking it down because it has to be broken down into smaller molecules in order for our muscles to really use it effectively. So this way we have that energy that we're looking to produce that our body's going to need for this event. Now, what we want to understand from here is what happens next, okay? Now, glucose is that byproduct of sugar, okay? And obviously we're talking about the good sugars. We're not talking about the donuts. We're not talking about the sweets. We're talking about the good sugar that our body's going to take. And we're going to use that in a process known as glycolysis. And that's where the glucose is going to be broken down and turned into energy. And this is what happens on that cellular level in the cytoplasm of the cell. So if we were to really, under a microscope, take a look at that cell, we would see glycolysis happening within that cell. That's where the glucose is really being broken down further. From there, what happens is we get molecules, mainly pyruvate, which is going to then enter the mitochondria, which is known as the powerhouse of cells. This is where the most action is going to happen and where we're going to see more energy produced in our bodies. And that's where we're going to see a release of energy going out into our muscles. So from here, we're going to then have a second where we want to really understand that glycolysis is where a small amount of energy is produced, okay? And I want you to kind of take a moment and really understand this a little bit further because we look at those gels, we look at those quick little sugar tablets and things like that. That's all simple sugar, okay? That's glucose pretty much in a pure form where we're looking at getting a quick burst of energy, okay? And that's what's happening at glycolysis. We're taking in that little bit of sugar, we're eating it, and we're trying to get a little bit of energy to produce in our body. And just so you know, energy is known as ATP, adenine triphosphate, and that is very important to understand because this is where now we're going to look at what happens in cellular respiration. Now, I really like this diagram a lot because I think it gives us a very clear overview without feeling like I have to understand a ton of molecules and what's happening and how much oxygen and carbon dioxide is being released and where's it going and how much energy is being produced. So I want to really kind of just simplify this thing. As you can see on the left-hand side, we have food. Food enters our body along with oxygen and it goes into the cell, and that's at the cystole level. And then inside our cells, we have mitochondria, and that's the bigger thing that you're seeing that looks like a peanut kind of shape on the screen right now. Initially, we go through glycolysis where the sugar is broken down. That's our glucose, and it produces pyruvate acid, which then is going to go into the Krebs cycle. Now, like I said, a little bit of glucose, a little bit of energy is produced in glycolysis, and then our Krebs cycle is going to produce a little bit more energy. But it's not until we take the byproducts that are going to happen in the Krebs cycle, which is known as NADH and FADH2, where those are going to go into the electronic transport and they're going to convert more energy for our bodies. That is really important to understand. Now, in this example that I'm sharing with you guys right now, we're essentially kind of really looking at glucose being the main fuel supplier that's going into this system. Now, I want you to step back for a minute and think about it. What would happen if I used protein or fat, and what kind of energy output would I get? Now, again, because I just told you, this process, usually we look at glucose first. You might be saying to yourself, why aren't we still carb loading? Why wouldn't carb loading be what I would want to do prior to an event, to have an successful event? Well, this is what I want you to really kind of understand from here. In this whole process, carbs or glucose only yields 38 ATP. That's energy when we're all done with the process, and that's going through the electron transport. If you were to utilize protein and fat, you're looking at almost tripling that number, okay? And these can range depending on the type of food, and you should be saying, wow, that's pretty impressive. If I was to use fat, I can actually get a lot more energy coming out of all this. Now, again, there's something I really want you guys to fully understand here. So when we look at, what to do post-event for nutrition, we really do look at increasing protein and water for tissue repair and recovery, because we all know that when we do these long endurance events, we have a lot of micro tears that are going on at that cellular level, and we need to go ahead and really kind of harness our bodies in terms of making sure we're decreasing the inflammation and we're repairing and we're restoring our bodies. So protein really does play a key role in that. So that's why the night before, it would actually make a lot of sense to try to have a little bit more protein. But if you were to have actually more fat as well, and I'm talking about the good fats here, guys. So I'm talking about the omega-3s, the omega-6s. I'm really talking about utilizing those the night before. What's going to happen is, during that whole process that we just looked at, from cellular respiration, you're going to go ahead and your body's going to use the fat first. And this is really interesting because your body will take whatever carb is in the body. Okay, so if you have any sugar left in the body, say you had some rice, jasmine, basmati rice the night before, your body's going to take that, it's going to break it down, it's going to take that glucose, produce a little bit of energy, but then it's going to know that it has some fat over here in a storage area, and it's going to start to use that. And now the fat is going to take a longer time to be broken down, but what's that going to do? It's going to give you more energy for that longer duration event. So you're going to notice that you're going to have a better outcome at the end. Now, I'm not saying if you have an upcoming event, I'm not saying go eat, something that you're not used to, but if you're preparing, especially right now, we're right smack dab, kind of getting our bodies ready for a lot of the upcoming big marathons. I would say, try this out, try a little bit, see what happens, go out and have a really nice balanced meal when it comes to fat, protein, and carb, and see what you notice on your next run, and especially what you notice for that recovery. I think you might be surprised. Now, if you have specific questions regarding this type of, technique when it comes to nutrition for training, please drop those comments down below. And as always, guys, if you found this video helpful on protein plus fat equals endurance, give it a like, and don't forget to subscribe to the channel. All right, everyone, this is Dr. Heather, your virtual sports chiropractor, and I'll catch you in the next video.